Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I wanted to talk about Azure from a physical perspective. In other words, I want to talk about the physical locations and the setup of the Microsoft Azure data centers. And I think two things will come out of this. First of all, a new appreciation for the scale and the investment and the manpower it took to put Azure together. Yet another reason why it shouldn't be ignored. And then secondly, and I think a little bit more pertinent for our purposes, is that there are ramifications of choosing a particular region whenever you create a new instance of a particular Azure service. And so this will help you become aware of that. So for starters, the actual servers that power Microsoft Azure live all over the globe in large data centers. So some of these are shockingly huge, some as large as 10 football fields filled with servers. I mean, the amount of computational and storage capacity is mind-boggling. So I'm going to point you to this great marketing video. Here's the link on screen right now. It's a marketing-oriented video. It's a couple of years old. It might seem a little dated, but it features a tour of the data centers, and basically it does a really nice job of explaining the hardware and the logistical challenges in developing a data center on such a massive scale. So it begins with the original data center that was created in Washington State, which is powered with renewable energy. It has massively redundant power generators and banks of batteries that supply power whenever there's a temporary outage. So the video then goes on to show how they design newer data centers, what they call Generation 3 facilities, and how the design has evolved to a more modular approach. So as an example, it tours the Chicago data center that was built in 2009. And so this Generation 3 design dramatically reduces the time that it takes to actually build and bring one of these data centers online. It too is 10 football fields and houses thousands of shipping containers that have been repurposed to be modular server farms. Very cool. Now, each of these shipping containers contains about 2,400 servers. So the containers are cooled using local water sources, and the total power efficiency of the design has won awards for using nearly half as much power as a typical data center. Then the video goes on to tour Dublin. In Dublin, Ireland, they have a data center, another Generation 3 facility. It was also built in 2009, and it takes advantage of Dublin's natural climate and its air and moisture evaporative qualities to create a system that utilizes that to help cool the servers in an energy efficient manner. So that video then goes on to talk about the additional evolution of the data center onto Generation 4, which requires even less electricity to operate and takes even less time to build. So again, I'd encourage you to watch that video after you finish watching this module. It's 10 minutes long. It's well worth it. It defies my ability to comprehend, much less explain, the scale of Microsoft Azure. So what is the significance of that, and why do I even bother to bring that up here? Well, there's actually a practical application of this knowledge. Whenever you create a new service, whether you're using the portal or one of the management APIs, one of the first pieces of information that you'll need to supply is the region that you want to provision the new service into. So you have to understand the taxonomy, how this works a little bit. At the top there are geos, and then there are regions, and then there are data centers. So a geo is a major region, including the United States, Europe, Asia Pacific, Japan. I'm not sure, but I think they have changed the name of that to Southeast Asia. I'm not really clear on that. Another geo is Brazil, and then the newest one I think is Australia. So each geo can contain one or more regions. And so if you take a look at this marketing page on the Azure website, I posted the link here, you can see that at the bottom it gives a list of the locations. So a given region may have more than one data center. For example, there's the US East region, which has 2 data centers, both in the state of Virginia. And you'll see that there's also a third region in the state of Virginia as well, but it looks like it's exclusively used by the U.S. government. So furthermore, these regions are split or associated with zones. And so you can see on screen some of the zones there. There's 3 zones. And you might ask, well, why does all this matter? Well, a couple things come to mind from a practical perspective. Whenever you build a solution that relies on Microsoft Azure, you're going to want to deploy all the services that you rely on in a single region in order to avoid network latency. Even the best network has some latency associated with it. So you're not required to do this. You could spread services around the globe for a single application if you want to, but if speed is your goal, then you'll want to consider putting them all in the same place. Secondly, if you do spread your services across the globe for a single application, then you have to worry about outgoing data costs. So this is where the zones come into play. If you have a service in Zone 1 that's utilized by Zone 2, in other words, the requests originate from Japan East and they're handled by a service hosted in US West, then you'll be charged for the outgoing traffic from US West and the outgoing traffic from Japan East. However, you don't have to pay for incoming requests at either location. So unless you have a compelling reason to do this, you probably should limit intra-zone communication for Azure services. The third practical implication of all this is that for public-facing services, for example, Azure websites, it's generally advised that you deploy your services to the region or the geo where your customers live. So obviously, no matter where you deploy your services, people from around the world will be able to access them. That's not really the point. Again, this is really a matter of network latency and the proximity of the data to the end user. So having said that, there are ways to provide a CDN, a content delivery edge, around the world to help speed up the transfer of common files like your images, your JavaScript files, your cascading style sheets, those static files that never need to change dynamically. And there are some other strategies that you can use to kind of cater to a global audience as well. But you generally want to put your dynamic pages wherever your customers already are. And then the fourth practical implication of this is that Microsoft might actually transfer customer data within a geo, so for example within Europe, for the purpose of data redundancy or other purposes. So for example, Azure replicates the blob and the table data between 2 regions within the same geo for enhanced data durability in case of a major data center disaster. Now, I'm not sure how actionable that is for you and I, but it's really nice to know that you get geo redundancy without having to worry about the additional cost if a failover happens. I don't have to worry about cross-zone, in and out, or actually outbound data costs. And then the final consideration with regards to where you put your services is that not all services are available in every region. So you might take that into consideration, especially if you're architecting a solution that you're targeting to deploy outside of the United States, which seems to have the full cadre of services available. Does Southeast Asia have all of the services that you need? Are you sure you want to deploy there? I'm sure over time, all of the regions, all of the locations will wind up having all the services available, but I think that's something they're growing to. And then one last thing, don't just take my word for it. You're going to definitely want to use what I've said as a starting point for learning more about the costs and the functionality associated with deploying to a given regional data center. But who knows? The pricing schedule could honestly change an hour after I finish recording this module. So here again, there's a powerful calculator to help you figure out your costs before you get too far, and you can find it at the link there on screen. So I'd recommend, if you're going to look at this link, looking at the full calculator tab all the way on the left-hand side and reading all of the small print to fully comprehend the gravity of the decisions that you're making, especially in those scenarios where you're choosing cross-zone or geo-regional boundaries. Okay, so I've told you everything I know about geos and regions and all that good stuff, and we can get started with some really interesting developer-centric content from this point on. Thank you.